And I'm going to talk about what we need from machine learning, artificial intelligence, ML, AI, whatever, from the perspective of someone who just wants to get tools that work, okay? Now, I'm not going to say anything dramatically innovative or this, that, and the other, but I'm just going to say this is how I believe we think as testers, and machine learning, AI, I think, support that thinking, that thought process. Therefore, we need to understand how we think, and then we need to understand where machine learning and AI can leverage that thinking and do it at great speed. But let me start just to introduce the meme that is this. Is not getting very many laughs, is it? Is that the future? I think that's the future that some people fear. I don't think that is the future. I really, really don't think that. So, but let's move away from this notion that AI is going to take over the world. This, that, the other. I mean, Fiona did a fantastic job of terrifying us and giving us some hope. I'm going to try and not suggest that there's a doom and gloom situation here. However, I have to talk about something very close to my heart, and that is engineering. The word engineering, the discipline of engineering. So, software testing and engineering. What am I going to talk about here? About a year ago, I got into a Twitter fight because this tweet came up on my timeline. Engineering is easy. You just estimate how many hours it'll take to do things nobody has ever done before, over and over, until you run out of time on the schedule. Now, I got into trouble because I thought, clearly, this was a joke, okay? And I treated it as a joke, but the person who posted it took offense at my comment saying, "You're confusing software and engineering. Ha, ha, ha." She didn't think it was funny. Anyway, I'm not going there. And I normally do show that dialogue, but I don't think it adds any value anymore. So I want to talk about when I was an engineer, because I did an engineering degree. 3 years, general engineering, and then a 1-year MSc in concrete structures. So I was going to build, I was going to design columns, slabs, concrete shells, you know, all that kind of good stuff. You know, great new buildings, you know, in the world. And on my first day, my first job with a consulting engineer, the boss said, "I've got no work for you today, Paul, but we've just had this computer delivered. Here are the manuals. Have a play, tell us what we can do with it." And my fate was sealed. You know, that was it. You know, I was into IT all of a sudden. I did a little bit of engineering, but not much. Anyway, the rest is history, I'd say. But what I want to do is use this notion of engineering and understanding what an engineering profession should look like and what an engineer actually does. I want to use that as a basis of making some suggestions about what technologies we need in the future and maybe where machine learning and AI fit in. So the first thing I want to do is, okay, that we all do, we go to a dictionary to look up a definition, and this is the definition of engineering, the first definition I'm going to pay attention to. The application of science and mathematics by which the properties of matter and sources of energy in nature are made useful to people. No mention of software there, needless to say. But I'm going to use that as a basis of the next few minutes, okay? I can see, and I know you can see, another definition a bit lower, okay? Which to me, it tells me nothing. You know, I don't like it. We'll come back to that. What do engineers do? So my first day at my job was I had a little desk, a very small desk, but I had a very big drawing board. And I spent 90% of my time sat on a stool with this drawing board. And, you know, it was like an A0 shape. And I drew stuff. And I drew stuff badly. And there was a draftsman in the office, obviously, who took my sketches and turned them into engineering drawings, much more sophisticated drawings. And the business that the company I worked for was in was basically water-based. So water management schemes, hydroelectric dams, and large-scale water management, all in Africa. A little bit in the Far East, but mostly in Africa. And this is an example of an earth dam, or an embankment dam, sometimes called. And when I rocked up on my first day, I had a calculator. I wonder, does anyone ever remember this calculator? Really? Oh, excellent. Join the club. We should set up a society or user group or something. This is the Sinclair Scientific. It was a scientific calculator. Cost me 27 quid in 1975. Okay, it was accurate to 2 significant figures. It was rubbish, you know. So I rock up to the engineers, and now all the other engineers have Hewlett-Packards, you know, and the prestige that you had as an engineer was the sophistication of your Hewlett-Packard calculator. So you had to have an HP calculator. Programmable, of course, reverse Polish logic, all that other good stuff. So the computer that I was shown to use, it looks like it's pretty ancient now. Well, of course it was. You know, this was 1980, no, 79, 80. And this is an AM Jacquard. It was called a mini computer, but really you could say it was a micro back in the day. It had no hard drive. It had 2 floppy disks, 8-inch, 200mm floppy disks, so big. If you take one of those and you throw it, it goes for miles like a frisbee. Fantastic. And it will blind people if it hits you. It's got quite a sharp piece of plastic. Don't do that. Don't try this at home. But one of my colleagues in the next bay was using Cray computers. This is Seymour Cray, with one of his machines, I guess. This chap is a Greek guy, or a Greek name. He was British, I think. And he was taking big boxes of cards down to the bureau to feed these cards into the machine to run massive calculations. Well, by those standards, massive calculations to calculate stresses and strains in embankment dams. You know, fantastic stuff. And then I got introduced to a VAX 11780, writing Fortran. Does anybody remember Fortran? Anyone used Fortran? Yay! Yeah, well, we're all over a certain age, aren't we? So anyway, whatever. I apologize. So anyway, going back to engineering, what do engineers do? Well, this is an engineer on site, and I'm going to talk about civil engineering because I know a little bit about that. What do engineers do? Well, they have to understand requirements, just like software guys do. They do site surveys to look at the environment. You know, what's the soil like? Is it clay, or is it rock, or is it gravel, or what is it? I'm not a geologist, by the way. They design, build stuff. That is, they design through modeling, I would say, complex structures in order to obviously define the shape of these things, the scale of these things, but also to understand the behavior of these things. And buildings aren't just static things, they're almost living things. They move. Even a breath of wind will move a solid building. A hurricane will move it more. An earthquake will move it even more, maybe. But they have to be designed in order to withstand forces that you might not realize actually exist, okay? Anyway, we have to plan complex projects. So a dam in Africa might have 5 or 15 or so professional engineers from Europe and 5,000 local people working on it. The unit of measure, I never realized this until I met some of the guys who had been to Africa and done their time, you know, on site, you know, usually 2 to 3 years. They'd say, back in those days, and maybe they were harking back to even older days, there's a thing called the stick, which is on site. And no, it's not for hitting the natives. It's the unit of measure. So that stick might be 1 meter long. And whenever any debate or discussion came about measuring distances, the stick was what was used. Okay, so, and literally, if the stick was lost or broken, it was a major setback for the project. That's kind of how it was. For example, test pits. I don't think it's called that anymore, but like holes in the ground that you dig to look at the soil conditions, where there's water flooding in and clay and all that kind of good stuff. They used to send the natives into those pits to get the snakes out before the engineers went in. That's the kind of environment that these people were working in. And my friend working on his Cray computer seemed kind of 1 million miles away, if that makes sense. At any rate, everything engineers do is they use models. Plans, designs, bills of materials, finite element models, mathematical models that describe the behavior of complex structures. These are all models, okay? Some of them could be fed into computers, quite often fed into computers to do clever stuff. But modeling is part of engineering. It's fundamental to engineering. Now, the other thing that I learned was engineers can't avoid measurement. Okay, well, so what? Yeah, well, obviously, you've got to measure stuff, haven't you? but also accountability and calibration. And by that I mean, I'm going to give an example, is, again, my first day, I was given a pad of calculation sheets like this. And if I just zoom in on the top, you can see that there's an area for, the admin, if you like. So there's a project number, sheet number, page 1 of however many, calculated by, that might be me, on a date, whatever, checked by. Every sheet was checked by another engineer, often a more senior engineer. Okay? Scale. Of course there's a scale, because you've got a graphical page, and when you pitch a drawing on that, it's got to be to some scale. So when you give it the draftsman, they can turn it into a real, a piece of art almost, very highly accurate, but manually created scale drawing. And so on, you get the idea. So we have this notion of configuration management. So whenever a version of those calculation sheets changed, you wrote SS and 2 lines superseded on every page. And then you started again. And some of the material you might reuse, but it was all done in propelling pencils and rubbers. Okay? Now, I guess most of this is done on computers now. But the concept of measurement, traceability, configuration control, peer review, all built in just to that piece of paper. Okay? That's what engineering is. Do we see anything like that in software? Not sure. Although I was writing programs for engineers, and I tested it to the best of my ability at the time, no one ever tested the software I gave them. The engineers just thought, oh, it should work. We're engineers. You don't make mistakes. But there was no concept of software testing in those days. Certainly not in that environment. We just experimented. If it didn't work, you changed it and you tried again, and But there's something that you may not realize, is engineering and scientific programs often has a physical reality that gives you a safety net for obvious bugs, let's say. For example, if you're analysing the stresses and strains in a bridge, and this was one of the projects that was going on while I was at this company, every girder, a piece of steel, okay, all the forces in 3 dimensions, sure, rotational forces in 3 dimensions, okay, have to balance. Otherwise, that piece of steel would go flying off into the universe somewhere. So you have this kind of fundamental checking that's done automatically, and you can write software to do calculations like that, and then you have a little process in your, typically a batch process, which checks everything to make sure every element is precisely balanced and isn't spinning around off into the, dare I say, internet. That's not really what I mean. You know what I mean? So you get it. So engineers typically don't do testing the way that you might do testing of other kinds of software, because there's this physical reality behind it. So is engineering easy? No, of course not. And I've taken what I would say is an old school view, although I have to say most engineers would agree with that kind of definition. They want to do good in the world, ultimately, okay, based on materials and using mathematics and the laws of physics. The problem we have with software is there are no laws of software like the laws of physics. Software does not obey any laws, none that I would trust, none that I would base the design of an aeroplane on. And let's not go into airborne software being as reliable or unreliable as you might want. There's no underpinning that there is with engineering in software. And that's why I say software engineering isn't really engineering. Now, let me finish this before you get offended, okay? Can I ask, how many people have got engineer in their job titles? Okay, now, I'm outnumbered, okay? By about 100 to 1. Please don't kill me, okay? The methods of software engineering work in their context. So high-integrity software is designed and built using the most rigorous approaches we know. Very clear design methodologies, peer review, inspections. Clean room software was a thing for a while. I don't know if it still works. If the context is right, Waterfall works, okay? And most software engineering disciplines are kind of more waterfall-oriented, which means that you have to get things right before you move on to the next stage, and you have to be pretty damn certain before you make progress in your projects. All that's great. However, most people are not working in high integrity or such highly ambitious projects where the ambition is to have extremely high levels of reliability and quality. Most of us aren't working in those domains. And so Agile, Waterfall, and some of the software engineering disciplines got a bad rep, bad reputation. And Agile comes along and it's, Hosanna, here we are, this is our savior, and so on. So continuous delivery, all that kind of good stuff, all came along as a reaction to slow, cumbersome projects. I want to suggest this, that calling ourselves engineers does not make us engineers, all right? And I couldn't resist, it's like, okay, well, we're on a pathway to engineering, and it's a bit like back of the car. I'm cutting out, I don't know why. Are we there yet? Has anyone got kids? Is this what they say whenever you go on a journey? Are we nearly there yet? Is this the last road? I'm not treating you like kids. I don't mean to do that. What I'm trying to suggest is that we need to think very carefully about what we believe engineering is and how we get to that place where engineering is what we do. That is, it's inbuilt. We don't question some things. We don't take shortcuts. We don't rely on other people getting us out of a hole. We have a process, we have tools, we have methodologies, we have methods, we have formulae, maybe. But essentially, we've got all the tools we need to make progress in this space. Now, I did say I'd mention this notion of the design and manufacture of complex products. I don't know if calling software engineering engineering. I don't think because it's complex, therefore we'll call it engineering. I don't think that's a good enough connection. Okay, that's what I'm trying to say. I think there's a heritage of engineering that's gone on for 6,000 years. We are still a very young industry. We're still finding our way here. And if we want to be engineers, we need to be talking about this kind of stuff in about 200 or 300 years' time, almost, So anyway, without getting too dragged down in that, I'm not denigrating what you guys do. Do not get me wrong. I'm just saying we should think carefully about what we call ourselves because there is a heritage that we may or may not want to take on in all this. And the challenge we've got is we need methods and tools to do some of the things that I would call engineering. Like, I don't want to be filling in forms when I work as a tester or a developer or a designer or an ops guy, whatever. I don't want to be filling in paperwork, right? Like those engineers were doing 40 years ago. I want tools to capture all that stuff without me even knowing. And I think that's possible. It doesn't actually need machine learning or AI. It just needs tools that do what we want, okay? And this is the challenge. We haven't got the tools we need to be what I would call engineers. We need to set a very high standard, and I think we've still got a way to go. That's what I'm trying to say. But there's an opportunity here. So let me introduce how many people are actually actively working with machine learning or AI in their systems? How many people are doing that? Oh, right, okay, 500. No, I think it's about 5, and I'll add 5, maybe 10 it's in the whole room. Very few people, okay? What does that tell you? There's an awful lot more hype than actually people doing this stuff. And the stuff that makes the news is either the disasters that Fiona was talking about yesterday or people trying to market stuff that is not yet ready for production use. Please don't shoot me down again, okay? I'm going to use a shorthand for machine learning and AI. I'm saying machine learning is software agents that offer suggestions. Okay? I'm just going to keep it simple. I know it's not that, but I'm just going to suggest that machine learning is software agents that offer suggestions, and AI is software agents that make choices or could be allowed to make choices. Okay? And I don't really care about the definitions. The two things I want to bear in mind is software that offers suggestions, software that offers choices or makes choices, if we allow it to. That's all it's about in my book, okay? No, I haven't written a book, I'm just saying in my world. So will testers be replaced by robots? No, of course not. And yeah, you could argue from history, well, we've been waiting for AI for, I don't know how many years, 50, 60 years? I don't know how long. I mean, they say that, what's his name? Who was the code breaker? Turing. Alan Turing, sorry, I've just lost. So Alan Turing basically defined, to a degree, what artificial intelligence might achieve, where you have a communication with a robot or a computer or some software, and they are indistinguishable from a human being. That was kind of the target, and we're not getting far away from that, and we're reaching the limits of, as humans, what humans can do to understand what is going on in the mind or otherwise of something you're communicating with. Did I just lose my voice then? Yeah, sorry, I'm cutting out for some reason. Will testers be replaced by robots? I don't think the answer is yes. I think it's no. But we will have tools that offer suggestions and make choices if we choose to take them, if we want them to. Okay? And I've been banging about on this kind of subject since big data came along. Because when big data came along, it opened our eyes to the fact that the big in big data wasn't about volume, just. It was about the diversity of data, the sources of data, the ability to manage, migrate, integrate, and then analyze data at scale. It was about all sorts of other stuff. And I thought, well, if I had all this data that I know exists out there in the world, it might not be being collected by computers, but I know a computer could do that. That's when I started talking about, well, surely there's things that big data could do for us as testers. Okay? So I've not been talking about this endlessly, but what it means every couple of years I kind of gave a talk and said we could do more, we could do better with our data in the testing sphere. Anyway, I want to talk about models for a moment and talk about something some of you may already heard of, which is the idea of a new model for testing. It's not new. It's about 10 years old now. But then New College, Oxford was founded in 1580-something. It's still called New College, okay? So it's a marketing thing. Don't get stressed by it. How many people recognize this picture? Oh, come on. Okay. It's all pervasive. There must be 500 variations of that one diagram. So every consultant has got their own slightly different version of it because they want to call it their own or make a point that they want to make with their clients. How many people recognize this picture? Oh, more. Okay. And I bet some more of you would put your hand up, you know. So this is very popular, isn't it? I think it dates back to maybe late 70s, early 80s. It's the V model. It's not new. It's 2009. I know it wasn't Lisa's model originally. Was it, I've forgotten his name now, the other guy who created this kind of thing. No? Okay, I'm looking at that. The V model is waterfall. This is waterfall thinking. Did you realize? Did anyone tell you that? No, of course they didn't. You know, just like Royce, the guy who actually invented, let's say invented waterfall, on page 6, the diagram, the waterfall diagram appeared, a bit like a turned inside out V model. It doesn't really matter, it's a topological issue. On page 7, he said, don't do this. And yet a whole industry embarked on structured methods, case tools, all the, I don't want to say the word, but all the, well, I will, all the bullshit that followed there. And some of it was good and most of it was bad. Okay? We're still using waterfall thinking. I've not got the slide here, but if you look at the, how do we describe DevOps? What's the diagram we usually see associated with DevOps and continuous delivery? The infinite loop? Unpeel that. It's waterfall. It's a staged process. You can't jump around. And in a way, if DevOps is about being very responsive, you don't follow this figure-of-8 loop. You jump around all over the damn place. It's event-driven. And we're still using waterfall as our underlying foundation, if you like. It's waterfall thinking. So we need to question the models that people are putting out there. And of course, everyone's got their triangle, pyramid, whatever you call it. Now, are these models useful and relevant? Well, they're useful for the first half hour of a software testing class. And how long does it to learn software testing? A lifetime, potentially. So, yeah, they're useful, but not very. Okay? They are not test strategies. Okay? If you think that's a test strategy, you've got another thing coming. So here's my thesis, here's my view about how we have to take on this challenge of can we get better value out of our tools, and in particular machine learning and AI. If we want to use tools that augment our thinking, that help us in our thinking, we need to understand how testers think, don't we? And I've never seen a diagram that says this is how you think about testing, what you think about and when, the flow of thought process, I don't mean the inputs and outputs and entry and exit criteria, I don't mean a process like that, just the different modes of thought that you go through during your day as a tester. And I'm not going to give you the whole story of this, but there is a basis to this model I'm going to show you. And basically, if we need to understand how we think as testers, we have to clear away all the crap that we have to deal with, all the, what I would call logistics, okay? And this is the way I put it, is for the next few minutes, I want to ask you to say, I will say this, I don't care whether you document your tests or not. I don't care whether you automate your tests or not. I don't care whether you're agile, waterfall, continuous delivery, something else. I don't care whether you plan your testing or you're exploratory. I don't care what technology, what business you're in, whether you're an individual or a team of 500 testers. I don't care. That's not relevant to how you think as a tester. Okay, so now we've now got a blank sheet of paper in front of us. You know, what's left? You know, there's nothing left, is there? You know, which is a bit terrifying. But I want to make the statement that all testing is based on models. Maybe it is engineering after all. Now, these models, sometimes we write them down. Sometimes they're given to us. We see diagrams, flow charts, sequence diagrams, collaboration diagrams, swim lanes, you know, technical architecture diagrams, use cases, maybe graphical, maybe not, I don't care. These are all models. User stories, these are all models, okay? Everything is a model. So the way we understand stuff in our brain is we build mental models to simplify the complexity of what we're dealing with. Okay? So when we're looking at a million lines of code system that we've got to test, we don't look at every line of code. We look at the technical architecture, and the technical architecture tells us maybe where the message paths between components are going to be testable and identifiable and testable, where the points of failure might be, and so on. If we look at the flow of control through code, not the code, but the flow of control, we can see where the decisions are and what choices we make and how many paths we can get through that piece of code to achieve some level of coverage. And every coverage measure we have is based on a model. It has to be, otherwise it's meaningless. It's a subjective view, okay? So even if our model is a simple list of requirements, we can have requirements coverage, and it's a model, and we have a coverage target that's objective, but it's not a very good coverage target, okay? Models are everywhere, and in anything I say, you know, from year dot and in the future, you could substitute model with the word understanding. That's what it is. The models we build in our head, and maybe write down, but they are our understanding. That's what those models are. They represent how we understand complexity and take a view on it, and simplify it, of course. So that's my first kind of statement from the top of the mountain, okay? Now, the next statement from the top of the mountain is all testing is exploratory. I don't want to get into a fight with you about the definition of exploratory testing. Let's use exploratory with a small e, okay? Like agile with a small e. There's agility and there's agility, right? Different things. All testing is exploratory because what we do is we explore our sources of knowledge. We read requirements documents if we've got them. We look at user stories. We interview people. We listen to what they tell us. we look at the old system. That will tell us what the old system does and what we might want to keep and what we might want to change. When the new system is available, that is a source of knowledge. Our knowledge is also in our head, and we reuse some of that knowledge. But that knowledge comes kind of impure because we have our prejudices and biases and failures as human beings. You know, we err. You know, we make errors, okay? We're human. It's human to make an error, isn't it? So we analyze source of information. Also, our source of information might conflict. Two users might disagree on what a feature should do, with good reasons. But that needs to be negotiated and settled before you can really make progress as a tester, or the developers make progress writing code. Anyway, we explore our source of knowledge, and in order to understand what those sources are telling us, we build models. Mental models, primarily. Some models we write down. But that's logistics. I don't care whether you write it down or not. See where I'm coming from? I don't care about whether you write it down or not. It's really important in some places. It's not important in others. It shouldn't stop us understanding how we think. When we've built those models, we think I know how this system should work. Therefore, I can do a bit of testing. Because I know what is going to be valid behavior or invalid behavior. Because I know from the requirements and the models I've built and my understanding, the models, I know what it should do. Therefore, I can run a test and say, that is a successful test. It does exactly what I expect. Or that is a fail because it doesn't do what I expect. The models inform our testing. And we have this notion of building our understanding to the level where I think I know enough now to do a bit of testing. Until that point, I'm still kind of figuring it out. Does that make sense? Yeah, we reach a point where we think, I know enough now to do something regarding testing. So that's from the mountaintop. Now, I normally do a kind of a halfway down, and this is at the bottom. This is in the foothills, okay? So this is what I end up with, right? It wasn't me. I ran a few workshops, 3 or 4, and about 7 or 8 people contributed to this. And I just drew it up, and I said, I think I've got a model here. And what this represents, it is not a process with a start, a middle, and an end. It's, if you like, the modes of thinking, and it's not drawn in a way like a state transition chart, but it's kind of a state transition chart. Enquiring is what we do to get information out of our sources of information. People, documents, systems, whatever. Modeling is building mental models. Oh, sorry, I wanted to do I beg your pardon, can I go back? I'll go forward now. I thought there was a pointer. There's no pointer. Or maybe there is. I just don't know what it is. Anyway, whatever. So the model's in the middle. We create these models. Written or unwritten, don't care. Okay? And then that informs our testing, and so on. So each black word, something ending in ing, is one of the 10 thought processes. Okay? And these are the 10 states our minds are in when we think about testing. Wherever we happen to be in the process, we're thinking along the lines of one of these states, if you like. If you're interested in I need to go back again, I beg your pardon. There's a YouTube video if you want a better explanation. I'm rushing that piece now. It takes about 15 minutes, okay, to do it properly, let's say. So this is how I believe testers think. I'm not saying you all think the same. But there's a process called inquiring when you're investigating, exploring requirements or sources of knowledge to get knowledge of the system. There's a process, a thought process called applying, okay, on the far right, where I apply tests. Now, I could have said run tests, or I could have said execute tests, or whatever. And I use the word applying to sort of not use the common terminology, because I did not want to get into the testing versus checking debate, which isn't a debate at all, because applying, I'd be happy if I called that checking, to be honest. But I didn't want to come down on one side that says, oh, checking is the way, and the rest of you who are doing the checking are idiots, and everybody else is testing, and we're supermen. You know, all that kind of bollocks, you know, which it is, right? I'm happy to say that. So anyway, so applying, checking, I'm happy to call it checking, is one activity in 10. Test execution tools support applying. Doesn't do any of the other things. Not one of the other things. It has nothing to contribute there. So test execution tools, the whole test execution tool industry supports one activity in 10 minimum, probably more. So if anyone says that we can automate testing, you know, I mean, everybody agrees who's in the testing industry says, stop saying that. You know, tools are not people. You know, they don't do what people do. They don't ask awkward questions of users. You know, so when we have a model, we can predict what the behavior of our system. And when we make a prediction of the behavior of the system, we can go back to the users and say, are you sure this is what you mean? And that's challenging. Okay, so each one of these maps to probably a software process that you already do day in, day out. All I've tried to do is to classify the states of your mind as you're going through these different processes. There's a ton of more stuff like, oh, finding test data. But that's not testing, that's logistics. Do you see what I'm saying? Where I'm coming from? So anyway, so I'm talking about tools, really. So most of the attention in the industry is on test execution tools or test management tools, although what's the most sophisticated test management tool we have in the industry? Excel. Still is, always will be. If we persist in tabulating everything. You know, tabulation is good, but there's so much more to it than that, isn't there? So I use the model to give my explanations of why automation is great but doesn't do everything. I use it to give my explanations of why we need to shift left. I use it to explain how we separate the notion of capturing test outcomes from interpretation and analysis and reporting, because they're different things. Because the thought process is different. They're not different because, well, you might say, oh, they're not different, they're all in Quality Center or some other test management tool. Yeah, well, you've handed over responsibility for a sophisticated process to a brute force tool in that respect. I'm not anti these tools. If you can make them work for you, fantastic. But I don't think we're adopting a very sophisticated approach. Okay, that's my point. And there's things I can say about, you know, I can now suggest that if we apply automation to systems where the requirements are muddled, loose, incomplete, flaky, whatever, you will never get automation working. It just won't happen. You'll end in a death spiral, you know. This is why automation attempts fail. They failed 40 years ago when I got involved with testing as a developer, not a test consultant, and so on, okay? So I use the model to explain all sorts of stuff better than other people, okay? It works for me. I'm not telling you how you think. So I think of test automation tools as logistics tools or mechanical tools. They are not thinking tools, which is what we need. So with thinking tools, if mechanical tools deal with logistics, and what we need is to understand where our brains add value as opposed to horsepower in software tools add value. I want to suggest that the majority of the test execution industry is providing tools for one aspect of what we do. It's less than a tenth of the number of states of our brain. It's probably 1 in 20, because there's all the other peripheral tools that we need for logistics as well, of course. You know, so I'm not dismissing that. It's really important. But in terms of the thought process, they only assist one. And you know, we don't really appreciate them. Not many people who use automation appreciate the tools in the way that they'd appreciate advice from a colleague, you know, or some decent bloody requirements, or whatever floats your boat. So the vendor challenge is not test execution. They are complex pieces of software, but we've solved that problem. You know, we should move on. Stop paying for it, you know. They're execution engines. They're a commodity. They should be a commodity. And I think that's the way the world is going. Okay? Good. Where's the value to the vendors? Because they've got to make money. Of course they have. So stuff like capturing models of the system under test. I can't tell you how important I think that is. Test design comes from models. Test selection comes from the models as well. Test data management comes from having an understanding of the model of the structure of the system and where data is used and changed and so on, and the schema of the database that sits behind all this stuff, or the messaging that we're sending out to other services and so on, so on. Frameworks become much easier because they become like an operations kind of toolkit. I'm not going to go into that nonsense, but you get the idea. And something called survey support, which is what I'm going to introduce as a kind of a mechanism for capturing models with tools. And if we can use machine learning and AI, all the better, but most of this doesn't require machine learning or AI. As I said before, I just want tools that work. So future tools, well, it's taken how long? 40 minutes to get here. Maybe you expected 40 minutes of future tools. What have we got here? Right, oh, I'm still talking bloody test process. Can I ask, how many people do structured, scripted testing? Okay, not a huge number. I'd say about 10, but I'm going to double that to 20 because, you know, you're shy. How many people do exploratory testing, as you would understand it? Okay, and I'd say about 400 people don't do testing at all. Okay, but it's 4 to 1, right? I think that's progress, you know, but as I say, I think all testing is exploratory. We don't explore. When you test something, you're not exploring it. You're conducting an experiment. You could call it exploring, but the exploring part is about understanding what it should do, because that's where it's a mystery. We know exactly what the system under test does when we run a test. There's no doubt about that. That's a mechanical process, not an intellectual process. That's not exploration. Exploration is an intellectual process, not a mechanical process. That's why the whole testing versus checking debate kicked off, but it's futile. We know what's an intellectual activity versus a mechanical activity. We already know that. We don't need to be told almost, even though I've told you yet again. So anyway, if I look at structured, well, it's got some good points. And if I look at exploratory, as it's usually understood, that's got some good points too. I'm not saying one is better than the other. They are just tools in our toolkit. But there are also bad points, I think, if things work. Okay? So structured testing is inflexible, not responsive, bureaucratic, outdated process. We don't do waterfall, you know, religiously anymore. Unimaginative, boring. Yeah, maybe true. Exploratory testing, oh, it's not repeatable, is it? Unless you write it down very carefully, you know, or you record it using a tool. Documentation usually goes a little bit by the by. Good note keeping is a fantastic support to exploratory testing, but we're human. We take crap notes, usually, and so on. Here's the point. And you could argue with people. I don't want to argue. I'm just saying there's good points, bad points. What we need, I believe, is the best of both. We need some structure in our exploration and our testing, and we need some fluidity, innovation, improvisation in our testing too. Of course we do. We need both. We need the best of both. That's what we really need, not it's us versus them as if it's the bloody Berlin Wall. It's not like that, okay? Or it shouldn't be like that. We shouldn't take sides in that respect. We should use what's appropriate at the moment of time. So what do I mean by exploration support? Exploration support is where, when I've got my hands on the computer and I'm examining and exploring the system under test, for example, I want the tool, I need a tool to capture everything I do and everything I observe, and more than that. That's what I mean by exploration support. Now, by capturing that data, I'm not going to be specific yet, I will be in a moment. By capturing that data, let's say the elements on a screen and the pathway I've used to navigate through that screen and other screens and throughout the system, if I capture that, the tool can build a map. If you capture all these different paths, they all intersect at a certain point, and you can build like a roadmap of paths through the system just by exploring and not doing any testing, just by going, I'll have a play with this, I'll look there, I'll do this, I'll do the other. Now, once the tool is building pathways like that, I think with a little intelligence, it could start making suggestions to us as well. Maybe it could automate those extra pathways, because it knows there's elements on screen, so it could build a picture of potential paths through software. And as soon as you do that, you can then come up with potential coverage measures. And I've not done any testing yet, but I could come up with a whole lot of pathways through the system. I wouldn't call them test scripts yet, but we're not far off. And we're not far off having automatable test scripts. Now, I know tests change data, screw up repetitions of those tests. Get that. But if the tool has access to the underlying database, if the tool has access to all the messages and can interpret the messages going into and coming from that database, it knows what data's changed. So it should know that, oh, I need to reset the database or take an allowance of the fact that data has changed. You could work it out in an afternoon what that process would look like. But we don't have software tools that do that. We can't do it manually. We've got to use tools to do this stuff. So that's what I mean by exploration support. I want to suggest the next generation of tools has to support what I would call surveying, like what engineers do. They survey the soil conditions. What we do is we survey the environment and the system in context, and everything that is relevant to our understanding of how it behaves, how it should behave, and how I can create meaningful tests. That's what I mean by exploration support. So, okay, so here's a map. What I want to get out of it is a map, a roadmap of all the nooks and crannies in my system that I can find through exploration or the tool doing some clever stuff behind the scenes. And I want to know what paths I can use. So if I want to go from A to B in a city from two places, there's all different pathways I can get there. So I'm not saying that we want to generate an infinite number of tests and, oh, that's great, but there isn't enough time in the universe to execute them. What I'm trying to say is that with tools that understand the production paths, because we want access to production logs, that can be used to influence which pathways through our test environment have meaning. Now, if we don't have any production data, we've got a bit of a challenge. We've still got to use our imagination and our intellect. But the day comes when we go into production, and then we're getting gold dust out of a production system, telling us what the users are actually doing in production. And that should be an input to our testing, not to just repeat what users do, I don't mean it that way, but to show what pathways are meaningful to the end users. That data is all available. We just don't get it. We don't use it. So, okay, this is going back to testing 101. Our initial model of software is we have a system, we put some inputs in, and we get some outputs, and we compare the outputs with our expected results. Bingo, that's testing in a nutshell. That's what people think testing is. I hope you know that it's a bit more sophisticated. Firstly, there's more than one kind of input. We have, I'm not going to go through this, you can read for yourself. There's at least 4. I mean, you could split these up and you could come up with other variations and permutations. You get the idea. There's more than one kind of input. It's not data in, results out, ooh, pass, fail. It's not like that. You know this, right? But we don't have tools that look at more than the inputs that are put in by human beings or what human beings could see or interpret through looking at the DOM in a web page. We don't go beyond that. And yet there's so much more going on in our systems, which causes a difficulty. And the outputs that we get are, let's say, those. But another output is the system itself might change. The system state itself is also an input. Now, there's variations on this kind of picture, this model of how you stimulate a system to behave a certain way to test it. Okay? But these are, I would say, they're outcomes rather than outputs, but what the hell? That's a bit of terminology. But you get the idea. I want it all. I want it all. I want it now, and I'm going to burst into song in a minute, you watch out. For all testers, for all time, in their environments. That's what I want. And I want machine learning and AI to look at all that data and tell me stuff I would never guess could occur. That's what I want. That's what we should all want. And we do, but we are given test execution tools, which are just robots that run scripts that we wrote. And that's it. Well, I want to swear, I really do. Not much. That's what I want. Now, OK, on top of that, oh, that all sounds very clever, Paul. How much of that needs AI? I don't think very much at all. Most of the technology to do all that stuff exists. We've got scanners and sniffers and capture tools and proxies and all this other good stuff. We can do all this already, but in fragmented pieces. No one integrates it all into one place and makes it useful and viable to do clever things. But essentially, our scalable, automatable process, it's not an automatable process. It's humans figure out the pathways by exploration through the system under test. And we could use a model. If we're doing model-based design and development, the model we use to create the code could be used to give us the pathway already. Maybe that is feasible in packaged solutions, potentially. But essentially, I think testers have to do the pioneering work. But once we've done that, tools can take the data that it collects as we navigate through systems and come up with all sorts of suggestions for things to cover. Because we've got it all. That's where we should be going. Surely that's where we're going. So we're not replacing the intellectual part. We're replacing the sheer number crunching boredom of looking at all these bloody logs manually. So I want a tool that looks a bit like a developer's IDE, but I'll call it an IT, an interactive test environment. It's not a very good, not very sexy name, I know, but I'm sure you could improve on that. I've got a mode called survey mode. I explore the system. Everything I do is captured. Inputs and outcomes, state of the system, configuration, and changes to state, changes to configurations. I've got a mode called edit mode, where I might construct some scenarios which are interesting to me that the tool will augment. It will fill in the gaps, if you like. I want to go from A to B, and it will give me the pathway. Whatever A to B are might be a change of data. Give me a test that will make a change to this piece of data in the database. I want the tool to do that. And it might say, you've got 5 choices. Bloody hell, I thought there was only one way of doing this. Only a tool can give us that kind of information. Only a tool can do that. We can't do this manually. I want an interactive test mode. I want to press a button and it runs a little test and I say, oh, OK, I see what's going on here. I like that. That's fine. Whack it in the library. We'll keep it. I also want an unattended mode. Now, that doesn't sound very exciting either. These are things that already exist. But some of the tests will be generated from the data we capture. Maybe analyzed by machine learning and AI. I don't know. That's where I think we should be. So test automation becomes a modeling problem, not a scripting or a programming problem. Now, some of you may already be using codeless or code-free tools, and fantastic. We should be racing in that direction. We don't want to be writing code. We shouldn't have to write code, I don't think. Code's fun, but it's another problem, I've got a problem. My tests run really slowly. OK, let's get some tools in. OK, now I've got 2 problems. That's the way it works, So my close. I've got 1 minute, 40 seconds. I might overrun a few seconds. This is kind of the question that you see, that kind of, should we automate everything? How many people are being asked to automate everything, whatever everything is? How many people are asked to do that? OK, why? Ooh, the boss says so, What do we lose if we lose the human factor? Well, I don't care if we lose that human factor, because applying is a mechanical process. But all the other stuff, all the other 9 thinking activities are intellectual to some degree. This is the wrong question. I think we should be thinking that tools are ever present, supporting surveying and testing. Okay, the whole 9 yards, right? From knowledge gathering through to test execution, interpretation, reporting, bug collection. The tester decides, what to explore and where. The tester decides when to run tests, when to file tests, delete tests. We make decisions. The tool might make some recommendations, like, how do I get from A to B? You've got 5 choices. Bloody hell, I need to test all of those now, don't I? I'll choose to do that. Can you run some tests for me? And I want it happening. I want it happening. I don't want to think about running tests anymore. Why would I? Why would I want to do that? I can't think of a good reason unless you really enjoy, I don't know, slavery, let's call it. Now, the tool decides to run tests when your back is turned. I think last time I gave a talk like this, I had this moment where I thought, why is the tool just sat there doing nothing when I'm going getting a coffee? Or why is it kind of seemingly doing nothing when I'm thinking? I want the tool to think, you know what, while you're thinking, Paul, I'm going to run a couple of thousand tests in the background. What tests are those? I'll tell you when I've run them. If I run them and nothing is of interest, you don't even need to know I've run them, other than the log has just got a couple of gigabytes bigger. Okay? I don't want to know the results of tests that have no meaning. I only want to know failures and interesting things that the tool says, you know what, Paul, this is interesting. This is could be an anomaly, could be a feature that we didn't document or we didn't have in the catalogue or whatever. I'm happy for the tool to do some stuff in the background autonomously. But it's not going to do a release without me knowing. It's not going to do a build or a commit or anything like that without me knowing, that's for sure. The tool will review the testing recently across the team. Of course, the models we create are across the whole team. I want the tool to tell me, Paul, you're wasting your time here. Tom, Dick, and Harry have all tested this in the last 3 days. They've really thrashed it to death. But there are whole areas that no one has been to yet. Would you care to go over there? And I might say, yeah, no, I'm going to do what Tom, Dick, and Harry does. I'm going to waste a whole lot of my time. Or I can go and do something new and interesting. That's what I want tools to tell me. You know, Tom found a bug here yesterday. Oh, really? Fantastic. You might want to look a bit more closely in this area. I want the tool to be telling me, giving me options for doing interesting things. Things that would take a week of analysis. Okay? Those are the things we should get the tools to do. To review the testing history, I want stats that we've never had before. All the data, all the time, all the tester, all the features, all the time. All the time, yeah. That's what I mean, okay? That's what I mean by the data we need. I want and I need and I want in my tools in the future. I want it all. We should not be satisfied with half measures. So, there's an opportunity. If we can make the case to get this kind of technology in our hands, okay, and it might be very expensive, but my, how much more productive we could be if we have this kind of technology. I want to move from being a victim at the end of the test process to being proactive and the most important member of the team apart from the lead, okay? I want to challenge and refine requirements, and I want tools to support that. I want to capture surveys in the system model. I want the tools to tell me what to do or to make suggestions of what to do. And quite often I'll say, yeah, you're right, always right. Yeah, that might happen. I want to be a pathfinder in the project, not a follower. Because I'm going to have more knowledge than any developer in the team about the behavior of the software that they've just written. So tools offer suggestions and can make choices, but under our control. And that's the message. It's suggestions and offering choices. Thank you.
Thank you, Paul. You can take a deep breath and relax now.
I'm cool. I'm happy now.
So I believe we've got a few minutes for questions, probably maybe just under 5 minutes.
No, that's the last time. I'm getting...
The countdown is on. So we've got a leaderboard. You can bear with me. So Streets Ahead is a question about what do you think? If software is written by AI, would it still require human testers?
Oh, you're looking at the second one. Oh, right.
I'm going by the highest votes.
I've no idea. If it's written by AI... interesting. If, let's say not AI, but a program. If a program wrote another program, and you test, how would you test it? Are you testing the software that's generated by a program, or are you testing the program that generated it? Because it'll always be perfect, won't it? But we've tried that, and it doesn't bloody work, does it? We're not smart enough to write programs that write programs. Now, AI might give us some hints, and I've no doubt there's people working on this stuff. And there was a suggestion a few years ago when the whole AI machine learning thing started to explode, that of 700 and something jobs, some of them were like guaranteed to be replaced by software and AI and machine learning, stuff like that. And one of them high up there was 50% of all programming jobs. Now, I don't know where that stat came from, but it was written by an academic, so I'm assuming that person knew of some research that was looking at automating the creation of software. But that's okay. Well, how do you create software? Well, you go and have an interview with the user, and the user doesn't know. What's it going to do with that? That's not changed. We can abstract as far as we like, but at some point there's got to be a human to something interaction. And it might be that we can write software to generate perfect requirements by asking the right questions at the right moment to people. But people have emotions, days of stress. They don't know everything. They might be in conflict with other people in the same organization. They might be a competitor with another person who... I don't know. I doubt we'll have software that's written by software anytime soon that has any significant meaning or impact. Can't believe it, to be honest. Sorry, I mustn't do that.
Okay, thank you for that one, Paul. Again, going on the leaderboard, the next popular question, I think you partially, if not maybe fully answered it in your couple of last closing slides, but what does a thinking tool look like? I think you defined what you'd want a tool to do.
I think a pretty pink flying elephant in the air. I don't bloody know. It looks like whatever you want it to look like. It's a thinking tool. So essentially, it's like another, dare I say, person keeping an eye on you, observing and monitoring what you're doing. You could say Big Brother, but we're talking about testing. Come on, you know. And it's going to come up with some advice. So my guess, it would be a combination. It would sit in the background as some kind of bot, and you wouldn't interact with it very much, except to speak to it, perhaps. And you'd say, bot do this and bot do that. And you'd have to create a kind of a domain-specific language to have a conversation with it. Or you could have a user interface, you know, and what that looks like, well, that's up to you. I mean, user interfaces are completely programmable now. So it will look whatever you want it to look like, I think, you know. I don't see it as anything very clever, to be quite frank. What it's doing under the bonnet is very clever, but the interaction will be like a trusted advisor. You know, it'll be giving some hints. It'll say, I've discovered something you might be interested in, Paul. That's the kind of hint I want. And you go and take a look, and you think, there's something in this. Tap, 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 and I'll have an explore. And then the tool will be keep an eye on me and said, Paul, you know what just happened? We didn't get the HTTP message going from your client to this service this time around. Is that a problem? I don't know. Let's look a bit more closely. And it's a partnership. It's doing all the heavy lifting, and I'm doing some of the thinking. You know, I'm guessing that's the way it should be. I'm in control, but it's just faster at doing some stuff than I am. And it helps. You know what I mean? I don't think this is science fiction. I think we could do this today if we spent like 100 million quid on a project. You know, I'm not angling for venture capital, don't get me wrong. You know, I don't think this is going to take 1 million man-years to make. I think this is 50 to 100 man-years. That's nothing in the bigger scheme of things. I don't know how many man-years went into creating Windows and whatever. It was something like 200 million lines of code. You know, Windows and Office is about, I think it's 200 million. Is that? I'm guessing it's about the scale. That's a hell of a lot of software. Nothing like that. Nothing like as complex as that to do this. I don't think. I don't believe. That's like a chess engine.
The gong has told you to stop answering questions now, Paul. Okay, fantastic. 2 pieces of feedback, just very quickly. I know we've run over slightly. One person said, more presentations like this, please. And a really good one here as well. It says, you may have just turned testing methodologies on their head. Thank you for the new train of thought. So with that, please, final round of applause for Paul.